Myself Shraddha and my teammates are Sharda, Kirtana and Archana. So we are going to present on the topic credit card fraud detections using machine learning. So nowadays in the digital era, online transactions have become more common, making the credit card fraud a serious concern. It is such as detecting such fraud and accurately is crucial to protecting the consumers and the businesses from the financial loss. We clearly state that our goal is to demonstrate how machine learning technique can effectively detect the credit card fraud. So minimizing the losses while maintaining the positive customer experiences. So let we start our discussing. Let me show you the table of contents what we are discussing. So problem statement, justification, background research, identification, data collection, algorithm selection, and evaluation metrics used, implications and flexibility, conclusion and summary. So let me discuss about the problem statement first. Problem statement, a credit card fraud detection is a serious issue that is leading to the financial that result in a financial loss such as security risks. Traditional methods have been used to detect the fraud, often struggle to keep up with the evolving evolving the techniques used by the fraudster. Machine learning provides an intelligent and data driven approach to detect the fraud and identify the fraudest activities more effectively. Here, credit card fraud is growing issue that leads to server financial losses, compromising the security with the rise in online transactions and digital payments. Nowadays, how everyone are doing the online shoppings and like that. Sometimes you pay before the delivery arrives you. So payment in the online transactions can also become sometimes a fraud. Have become more sophisticated, making them harder to detect it is a using traditional method that it is a fraud or not. These are the conventional techniques like manually monitoring and the rule-based system are often slow and inefficient and fail to adapt the new fraud tactics. So machine learning offers more effective solutions by analyzing large database. So identifying the complex patterns and making the predictions in the real time by learning past data from the data learn machine learning model that also detects the unusual behavior and suspicious transactions financial damages occurs. This proactive approach is crucial to minimizing losses and enhancing the security of the financial system. So this is the problem statement. So let me explain next justification. Justification, a credit card fraud impacts individual and the business and the financial institute. It also negatively impacts the individuals who may face unauthorized charges and businessmen that suffers from the reputational and financial loss and a financial institute that bear take the burden of the like as the fraud techniques became more advanced and take the burden of the reimbursement techniques as a fraud the techniques have become more advanced. There is a growing need for the dynamic and the intelligent solution. So machine learning can also examine the vast amounts of transactions data. It also identifies the hidden patterns and quickly differentiate the difference between the genuine and the fraudulent activities. It also adopt the new strategies. It also adapt the new strategies which ensure the higher accuracy in the detection. So we are here it reducing the false positive where the ultimate transactions are flagged as a fraud. It also improves the customer's experiences, it minimizes the transactions and the dispersions. Furthermore, machine learning models can also handle the complexity and the scale of the modern financial transactions. Unlike the manual methods, or they provide the faster and more accurate results, making them a valuable tool in combating credit card fraud. So, experiencing the illimited transactions from being blocked. So, next will be explained by Sharada.
Identification of a key variable, transaction amount, transaction time, location, device IP address, transaction frequency. These are the identification of key variables. Basic needs of get a credit card is a age requirement and proof ID and proof income and a uh, bank account, credit history, address proof, a phone number, email. These are the basic needs to create a credit card. And transaction amount or, for example, John usually spend around 1,000 rupees or 2,000 rupees per transaction. Suddenly, there is a 50,000 purchase. The system flags is surprised because it weighs outside his normal spending. This makes to time. Example: Sahana always makes a purchase during the day. On one day, at a night, 3 a.m. her card used to buy electronics. Since it is an unusual time for her, the model makes it as a potential fraud. Then it is a location. For example, Raju lives in a Mumbai and has a never transferred a road. One day is card used to a loan that a red flag because that location is unaccepted. And a device IP address, for example, Priya always shopping online from a laptop. Suddenly there is a transaction from a new phone in a different city. That's why the model sees that's an unfavorable device and risk is then alert. Transaction frequency. For example, after a month of a normal use, a Niles card is suddenly used 10 times in a 1 hour. The suddenly burst could mean a stolen card become used before is blocked. Merchant category. For example, a card that's only used for crucius of a flues in now used to buy a luxurious watch. The change is a merchants types of a suggest a fraud. Then evolution, identification of a key variable. Basic needs gets a credit card is age requirement, proof of ID, proof of income, bank account, cra- credit history, address proof, phone number and email. For example, age requirement is 18 years old, must be at least 18 years old. Proof identification is passport, national ID card, driving licenses. These are the proof IDs. And proof of income needs job salaries, frequency income, business income. Bank account needs HDF, ICIC, any local bank account. Credit history needs a, a person with a precious loans or credits card usually paid on time. Address proof is agreement, bank statement. Proof, phone number and email proof are needed. Transaction amount. Example, Janu usually spend around 1,000 and 2,000 per transaction. Suddenly there is a 50,000 purchase. The system flags is a surprisingly because if it is a waste, outside is a normal spending. Transaction time means Sahana always makes a purchase during a day. On one day, a night at 3 a.m., he is usually used by electronic. Since there is an unusual time for either, the model makes it a potential fraud. Then location, for example, Raju lives in Mumbai and as a never tra- traveled abroad. On one day, his credit card used in all London. That red flag because that location is unaccepted. Then device IP address. For example, Priya always shops online from her lab. Suddenly, there are transactions from a new phone in a different city. That model says that unfair device or risk is an alert. Then transaction frequency. For example, after months of a normal uses Anil's cards in suddenly use it 10 times in a 1 day, 1 hour. That sudden burst code means a strongly card being used before it's be locked. Merchant credit category. What it means merchant category. For example, a card that only used for a gracious and fuel in now used by a luxurious watch. The change is merchant type of may suggest a fraud. Then evolution matrix used. Accuracy. What it means. For example, out of 100 transactions that models got 95 correct, so actually is 90%. If only 2 out of 100 are fraud and models predict all 100 as a not a fraud, it still gets a 98 right, that 98% accuracy, but it missed all the frauds. So it's not always usually when a fraud case or rare. Precious. What it means. For example, model says 10 transaction or fraud, only 6 are actually fraud. Precious is 6 divided by 10 is equal to 60% of fraud. When it is matter highly precious means fewer false alarms. We don't want to a blocked genius use it to a phone. Recall. What it means a recall. For example, there were 8 real frauds. Model catch a sixth recall or safe. Then F1 source, what it means. For example, it precious is a 60% and real in a 75%. F1 source gives a one number to represent a both. Best example for best for imbalance data like a fraud detection where a fraud case are much fewer. ROCAUC, what it means. Tell how will the model can tell a different between a fraud and not fraud. For example, if a AUC is at 1.0 perfect model, if AUC 0.5 a guessing are randomly. A help choose that a best cutoff a point of a discussing a what fraud and what it is. Confusion matrix. What it means shows a table of how many frauds and normal transactions were predicting correctly or incorrectly. For example, helps understand exactly where the model make a mistakes. Next slide, next slide explained by Kirtana.
I will be explaining data collection. First one is data source. We use this freely available data or real transaction record from banks. And data preparation means we fix any missing information, adjust number, and convert text category into numerical form. And substance. This means if there are lots of fraud compared to normal cases, we use a technique like smooth to create more fraud example or reduce the number of normal cases. And feature selection is we choose the most important piece of information to help our model work better. And data splitting means we split our data into training, validation, and testing set to see how well our model performs. Next slide. And next slide is background research. In our traditional method, older fraud detection mostly use rule and manual checks where can be slow and may not catch everything. Changing fraud pattern, frauds are always finding new ways to cheat the system. So we need to better method that can adapt. Machine learning. Advanced method like decision tree, random forest, and neural networks learn from example and do the better job to find fraud. Dealing with imbalance. Share imbalance cases are rare. We often have to oversample. The fraud cases are under example, the normal ones. And the challenges are we still need to reduce the raise alarm when normal transactions are flagged as fraud and manage every data. So next slide will be explained by Archana.
Hello everyone, I'm going to explain algorithm selection. Here are many, we can use many different algorithms in machine learning uh, for credit card fraud detection, logistic regression, naive Bayes decision tree, k nearest neighbors, random forest. Logistic regression is effectively classification by implement the uh, fraud detection. Navy base works well with the probabilistic models, scattered data, and many. Decision tree in machine learning, decision tree is telling about we can easily analyze the step by step process. It is simple and easy to understandable. We can make decision easily by step for transaction. K nearest neighbors. It is good for detecting the patterns, computationally expensive for large data set. For past fraud detection, comparing the uh, past fraud detection to uh, select the credit card fraud detection, random forest, and ensemble method that improves accuracy reduce over 15 by the with the help of decision trees. It can uh, improve the accuracy. Next slide. Implementation and feasibility. There are tools and technologies using by with the help of Python. Python with libraries like Pandas, NumPy, and Metabol Lib for model training and evaluation. Here are implementation steps. Data pre-processing. It is for cleaning and pre-processing the data. Feature selection. This is for uh, uh, credit card fraud detection. Model training for teaching the fraud detection, comparing with the past fraud detection. Modeling evaluation is the testing the um, credit card detection for last time transactions. Feasibility is a it's telling you about it can be integrated into banking system for real time fraud detections. It can handle the large transaction volumes efficiently, reducing manual fraud detections efforts. We can identify identify the fraud detection by comparing the large numbers and past fraud detection and last time transaction values. That's next slide will continue by
Conclusion and summary. Overall topic, credit card fraud detection. The credit card fraud detection model shows limitations, accurately identify limited transaction but failing to detect a fraudulent ones. This identicate a potential issues like a class imbalance or insufficiently transacting. Improving a data balance used advanced algorithm and optimize the thresholds can enhance the performance. Further optimize is necessary of a reliable real world application. For example, imagine a system that currently let you are busy but don't stop their thief from a busy buying a new phone with your card. That what happens, the model was a good at saying this a normal but not a good enough at saying this fraud. Why this happens? For example, there were a way more normal transaction that a fraud, so the model mostly learned to say a not fraud. The model may not have been traded enough or with the right balance of data. How we fix, how to we use to improve this? We can balance the data, give the model more fraud examples or learn from. Use a strong algorithm like a better mechanical learning techniques. And bottom line, the the model is a good start but need more work before being used to other real world like bank or payment apps. Thank you for watching.